Hello guys, Jose Ortega here with another technical video about network architecture implemented by network engineers. As you can see here, we have what is called a three-layer architecture. Um, for example, we have the access layer, then we have the distribution layer, and lastly, we have the, the core layer. Okay, these are the main three layers that network engineers use in medium and large organizations to implement and basically operate networks. But each layer has different functions for better network um, management. So I'm going to start, for example, let's say on the access layer. On the access layer, we're going to implement the VLAN information for the different departments that the organization may have. We also want to implement probably for security for security, so people that are not supposed to be connecting to the access layer switch cannot connect it. And on the distribution layer, we also this is where we're going to implement policies policies like quality of service. It's a very important policy. What this quality of service does, it provides preference to different types of traffic in the network. For example, let's say voice and video are more important in an organization, um, because video requires, in order for you, let's say voice, for example, um, you want to give preference to voice over data, because if you don't give voice the preference, then when uh, a user is trying to make a call to another business or something like that, then it's going to have very poor connection, and he's not going to be able to communicate with the other person that is located in another network or in another country or whatever. So that's why it's important um, to give preference and to give to establish a good quality of service policy on the distribution layer. Okay, just keep that in mind. And lastly but not least, we have the core layer. Um, the most important function of the core layer is going to be the speed, the speed for the network. Okay, that's the most important thing. For example, if you have a campus with three or four, five different buildings, and you want to have fast fast connection to the resources, that's what you need to have. The high end devices right here on these two core layer switches right here. You want to have you want them to be reliable, scalable, and you want them to have a very good bandwidth. Um, what you can see right here on this core layer. Um, Hold on, guys. Let me just erase this right here for a minute. Um, as you can see here on the core layer, we have four physical links. Okay, but those four physical links, let's say, is only one link is like 1 gigabyte. Okay, so let's say we have four links, so it will be 400 gigabytes. I mean, I would say this is 100 gigabyte, right, for one physical link. So we got four links, so we got 400 gigabyte link. Okay, but let's say, for example, the traffic is only going on this link right here. Is saturating the link. It's just keep going to this link right here. So that's why we're going to use a technology that is called Ether channel. Okay, Ether channel. This technology is about bundling physical links into logical links. So, for example, instead of having 100 gigabytes per link, logically we have 400. Okay, so the traffic is now actually can use the 400 gigabytes, and is treating the link as only one, as a one logical link. Okay, so that's what this technology is all about. It's very useful and it's very good for networks. Okay, another way you can understand it is by think of Ethernet channels as a highway. Instead of having two lanes for people to travel, you can have four, five, six lanes. Okay, increasing the bandwidth. Now, not necessarily the speed, but the bandwidth. Okay, so think about it. And the good thing is, if one physical link fails, the other three continue to work. So it's a very good technology to implement, and just keep that in mind. And lastly, but not least, we also have what is let me check this. Hold on, guys. We have the router that is connected to our core layer. We have it right here, and then from there, uh, we're probably going to implement NAT, network address translations. I'll go into detail about it in the next video, but that's basically trying to hide our internal IP address from the public. Okay, that's what network address translation is all about. It adds a little bit of security, not a whole lot, but it still is good to have and to implement. Um, and then from there, we just our service provider, internet service provider, connect us to the rest of the world, to the internet and stuff like that. Another thing that I forgot to mention here, guys, is the, for example, you can see these links right here. We have redundancy. So, for example, access switch 1 is connected to switch 2, and then it's connected to switch 1. So, for example, we have a lot of users on this device right here. We have a lot of users, and let's say we only have a connection to the distribution switch. That's the only connection we have. So, if it goes down, that means all of these users, they lose connectivity to the network. Okay, so by having redundant connections, redundancy here, even if this link goes down, all these users here will still have connectivity going through that switch right here, and then from there going to the rest of the network, and then go to the internet, or for example to other buildings where we have connections, and we still have a connection. Okay, so that's why the redundancy is very important in today's networks, just to have the business running and minimize the downtime. That's our main goal as a network engineers: minimize downtime, because it's very important in today's world. So that's it, guys. That's just a high level overview of how network architectures works, and another thing that I forgot to mention. Well, that could be in another video. There are other network architectures where we can get rid of, for example, if the if the organization is not so big and we don't have different locations, we can get rid of this. We can get rid of this. We don't need that, and we can implement our Ethernet channel here and use our distribution layer. Use this to connect to the router, and then to connect to the rest of the world, and then from this connect to other distribution switches, which will be in another building, and then connect to other access layer switches and have redundancy as well. But that will be just in another video. But I just wanted to let you guys know that, yeah, we can get rid of of the three layer and have a just a two layer architecture. But that's just that will be in another video. I just wanted to show you this one first, so you guys have an idea of how computer networks works. Just a high level overview. Okay, there's a lot of things going on in these three layers. So just keep that in mind. I made it look a little simple, but this is more complex than that. It's a lot more complex than that, and there's a lot of technologies involved. Like, for example, one of the most important technologies that we're going to discuss in another video would be the spanning tree protocol. Okay, that is essential to prevent loops in the network. But again, that will be in another video. But I'm just bringing this up just to let you guys know that as you get into more depth into the topics and into the network architectures, things becomes more complex um, to grasp, uh, to explain, to train, or also to show others. So let's take it little by little. And if you're one of those people that are just learning computer networks, so just take it easy, learn the fundamentals, um, and then from there start learning about the different technologies that are implemented in each layer. Because once you learn the fundamentals, and you can progress to more advanced topics like I said, STP, um, Ethernet, Ethernet channel, QoS, um, static routing is another one. Well, it's something like that, static routing, or looking at IP routing protocols is another one, like OSPF, um, IGRP. Um, Also, we can implement inter-VLAN routing. That's another topic that is very important, inter-VLAN routing. And I'm just mentioning all these technologies just to give you guys an idea or what you are getting into. But little by little, I will make small videos shorter than this one for sure, because I think this video is a little bit over 12 minutes now. I wanted to be a lot shorter than that, but I just wanted to guys just give you a little bit more information about the different technologies that you're going to be able to see in these networks. So that's it for today, guys. I hope you enjoyed the video, and if there's something that is unclear, just send me a message and post a question, and I'll be happy to try to answer it for you. If not, just you guys have a good day, and I hope you enjoyed the video, and I'll see you on the next one. Thank you, guys.